A trapezoid is a quadrilateral with one pair of opposite sides that are parallel, called bases, and one pair of opposite sides that are not parallel, called the legs. Similar to the altitude of a triangle, the altitude or height of a trapezoid is perpendicular to both bases. In order to determine the area of a trapezoid, we need to follow a sequence of steps. The first step is cutting the trapezoid in half horizontally. The second step is to rotate the top half 180 degrees and move it so that it lies next to the bottom half. What new shape is created? After cutting the trapezoid apart and moving the pieces, we can see that a parallelogram is formed. If you'll recall, the area of a parallelogram is base times height. How could you calculate the base of this parallelogram? Well, we can see that the entire base of this big parallelogram is the sum of our two bases. So base 2 plus base 1 will give us the entire base of this parallelogram. So add up the two bases, or base 2 plus base 1. It could also be written as base 1 plus base 2, because if you'll recall with addition, the order in which you add does not matter. What we found was that the bases, if you add them up, base 2 plus base 1, you get the base of the parallelogram. Now, how would we calculate the height? Like, what is the height of this parallelogram? Well, if we were to actually take the trapezoid that used to be the top and put it back there for a minute, we can compare the height of the trapezoid with the height of this parallelogram. So let's actually go through and count the heights of both. So the height of the original trapezoid in this coordinate plane is 1, 2, 3, 4, 5, 6, 7, 8. The height of the trapezoid is 8. The height of the parallelogram is 1, 2, 3, 4. How are 8 and 4 related to one another? Well, this 4 is half of 8. So that's 1/2 the height of the trapezoid. And let's actually re-rotate this and put it back where it was. And we can clearly see that this is half of that original trapezoid height. If we use the area formula for a parallelogram, which is area equals base times height, and we substitute in the base and height values that we found, which are, this was base 1 plus base 2, or base 2 plus base 1, and for this entire base, so in for this B we put base 1 plus base 2, and then for this height, it's 1/2 of the trapezoid's height, fill that in, we get this equation. And by the commutative property of multiplication, we can reorganize the numbers that we're multiplying together and put the 1/2 times the height before the sum of the bases. So therefore, the area of a trapezoid formula is 1/2 times the height times base 1 plus base 2. Find the area of the trapezoid using the area formula. Well, now we know that the area formula for a trapezoid is 1/2 times the height times the sum of the bases. We can apply this formula to calculate the area of this one. So in this problem, our height is 10 centimeters. How do we know? It's perpendicular to our bases, and both bases are parallel, so it's perpendicular to both of them. So the 10 is our height, so we have 1/2 times 10, and then we add up our two bases, which are 12 plus 9. And then if we simplify this, half of 10 is 5, and then the sum of 12 and 9 is 21. And if we multiply 5 times 21, we end up getting 105 square centimeters. Find the area of the figures using the formula for the area of a trapezoid. Well, we know that the area of a trapezoid is found with the formula 1/2 times the height times the sum of both bases, or base 1 plus base 2. In our first problem, our height is perpendicular to our bases, so that's 7/10 of a centimeter is our height. And 1 2/10 of a centimeter is going to be one base, and then 9/10 of a centimeter is going to be our second base. So let's take these values and substitute them into our formula. So area equals 1/2. Again, our height is 7/10, and the two bases that we're adding together is 1 2/10 plus 9/10. If we add up 1 2/10 and 9/10, we get 2 1/10 centimeters, and we still have the 7/10 of a centimeter and the 1/2 in front. And then if we multiply all these together, we will get 735 thousandths square centimeters for the area of this trapezoid. Now let's calculate the area of the other trapezoid. In this problem, we have 2.5 meters is one base. We have 3.25 meters as another base. And the segment that is perpendicular to both bases is this height of 1.5 meters. So that's going to be our height. So now let's take these values and substitute them into our formula. The area equals 1/2 times the height, which is 1.5, times the sum of our bases. So that's 2.5 plus 3.25. Well, in order to add and multiply, it's best to put fractions in improper fraction form. So we still have the 1/2 that's in front, and we'll convert 1.5 to 3/2. 2.5 becomes 5/2, and 3.25 becomes 13/4. And now in order to add these two fractions up inside of the parentheses for our bases, we have to have a common denominator. We have 5/2 and 13/4. 4 is the least common denominator, so the 5/2 converts into 10/4. So I'm going to replace the 5/2 with 10/4 or 10/4. And now we can add these two values up. When we add up 10/4 and 13/4, we get 23/4. And we still have 1/2 and 3/2 out in front. And if we look across the numerators and denominators and compare them, we don't have any values that can cancel each other out or divide out. So we're going to just multiply straight across. 1 times 3 is 3, and 3 times 23 is 69. And then 2 times 2 is 4, and 2 times 2 is 4, and 4 times 4 is 16. So then if we divide 16 into 69, it goes 4 times. and that's 64, so there are 5/16 remaining. So our final answer for the area of this trapezoid is 4 5/16 square meters.